Hello everyone, my name's Daniel and I'm a programmer and an artist. And today I thought I could talk a bit about the new scatter node that I added to replace the old scatter object and scatter collection nodes. Because if you didn't see, I updated my geometry node assets and I fixed a bunch of problems. I'll put a link in the description to those notes if you want to read those. And part of how I discovered all of those problems was because I was also making a website, and on that website I was making preview videos for all of the nodes. They just sort of briefly show what a bunch of the settings on the nodes do. And so, because I was touching every setting, I found all of the settings that didn't work quite how I thought they should. So my website is up and it's live, it's danielhickox.com, and it has all of the nodes on there, and you can click on them, see what the node itself looks like, see what the description of the node is. I might try to update those descriptions in the future. I kind of want to put on the nodes where it's relevant links to YouTube videos where I discuss the node in more detail. And then they all have a little demo video that loops and just sort of shows it being used, the settings being changed and stuff. All right, let's take a look at this scatter node. So what happened was when I made the video about selections for getting started in geometry nodes, I made this demo scene that was like a landscape. And I thought it would be a cool looking scene to use for the demonstration of the scatter nodes when I was making the demo videos for them. When I tried to make a video to demonstrate it, I was annoyed that there was no way I could use the selection I made that makes the trees not grow in the water and not on the road and whatever. And I also felt like it was kind of pointless to have the two different nodes because you can do some clever things in the node to allow it to use either objects or collections. Another thing that I wasn't too keen on about the old nodes was that they both forced you to use a scattering mesh that would eventually be deleted, but they would create points on that scattering mesh and then raycast them against a collection. And the reason for that is because if you're making a landscape, that landscape might be composed of multiple different objects. You might have some pieces of land in one place and then some cliffs and some other pieces of land that's a separate mesh. So for that application, the old nodes were super flexible because you could scatter on this third mesh that could overlap any of the other submeshes. They could all be in a collection, then you could raycast against that collection and place them on all of the objects at the same time with your one control mesh. However, for simpler cases like for this terrain, which is all one mesh, you don't even need this control mesh to scatter necessarily. You could just scatter directly on the object. So I wanted to add the ability to do that, but also keep the ability to raycast against a collection and scatter on a temporary mesh. So I think those were all my goals when I decided to go ahead and replace the nodes. I wanted to merge them into one so that you could scatter either an object or instances from a collection. I also wanted to allow it to support selections, and I wanted to make it so that you could choose whether you wanted to scatter on the input mesh or if you wanted to scatter on a temporary scattering mesh and then raycast against a collection. So I guess let's go through all the settings first. The first option is the raycast target. That's optional. If you don't pick one, it will scatter on the surface of the input mesh. If you do pick a raycast target, which is a collection, it will do a raycast using the normal direction of the scattering face and place the instance at the collision point. Then there's an option if you want to delete the input geometry. So if you choose that, then that scattering plane will get deleted at the end of after the trees have been scattered. Then there's an option for a mask name. This is the selection field. It can either be on the scattering mesh, or if you're using the raycast target, it can be on the raycast target. That can be either a vertex group, where you select some vertices and you say, I want the instances to only be on this part of the mesh, or it could be an attribute that you create. So for example, on this terrain, I have these geometry nodes that we set up in the video about using selections, and I just changed the forest one at the end to not scatter the trees, and instead it just stores a named attribute called selection, which is a Boolean value for the part of the mesh that we chose that we wanted to scatter trees on. But you could also go into edit mode, select some part of the mesh, and then create a vertex group and assign those vertices to that group. And that would also work as a selection. So then we could test that out. We could set the mask name to group. And now you can see only trees where we selected in the group are. Or we could make it selection. And now there's only trees based on the selection from this geometry node setup. Then there's a preview mask option, and what that will do is just draw a vertex on all of the selected faces. So that way you can preview if your selection is working and what parts of the input geometry it considers valid for scattering on. So we could change that to group again. And we can see this is the selection of our group, vertex group. Then there's some settings to control how many objects are scattered. So if we turn this all the way down, there'll be less trees. If you turn it up, there'll be more trees. Then the density minimum value works kind of the same. It controls how close together objects are allowed to be placed. So if you turn that up, they'll be spaced further apart. Then there's a seed value, which just will give you the same general look, but a different configuration of it. Then there's some options for what we're scattering. We're currently scattering this tree object. We can also add something else here. And we could move this to a new collection called collection. And then if we select that collection, it will scatter both the object and the collection. And we could go in here, select that cube. We could add an icosphere. And you can see now we're scattering the tree, the icosphere, and the cube, and it's picking between them all. So then there's some settings to control how the objects are placed on the mesh. The rotation variance controls the X and Y randomness of the object's rotation. And then the spin variance controls the Z rotation. Because for the example of the forest here, you might want to spin all of the trees randomly so that they're pointing in different directions, but you don't want the trees to be sideways. Then there's an option to match the normal of the surface. If you turn that up to 1, then the Z-axis of the instance will align to the normal of the face it's placed on. Then there's just some settings to control the size. If you change the scale, the objects get bigger and smaller. If you increase the scale variance, it will pick a scale randomly between a maximum of that scale value and 0 if you turn scale variance all the way up to 1. And then the scale randomness will break the uniformity of the scaling, so it can squish and stretch the object if you increase that. Alright, so then to go through the node, this is the whole node tree. As far as sort of the different areas of the node group go, this area down here is to do with the instances or the object that you're scattering and calculating the rotations and scales for it. Then this part up here has to do with creating those points that we want to scatter those instances on. Then at the end here we have the actual scattering of the instances on the points. And then depending on what settings are checked, we might merge the input geometry back in, or we might show the preview of the mask instead. Then this part up here at the top has to do with raycasting, if there is a value in the raycast target slot. So I think we can just kind of go through this part by part, and the first part here has to do with creating the instances. Since I wanted to make this node work either with a collection or an object, or both, what we have here is a collection info node and then an object info node. Then we have the object as an instance, and we join those two geometries together. So essentially what we're doing is adding the object to the collection. If the collection is empty, then you only have the object, but if there is a collection, then it gets appended to that list, essentially. Then there's a bunch of nodes here, but they're all just calculating values. So the actual next thing we do is scatter those instances on the points. We want pick instance to be true, and then the instance index, the rotation, and the scale are all of the values that we're calculating. So let's go back over here. The instance index is a random value between 0 and the maximum of the domain size of our joined collection and object set of instances. Then we just have a group input for the seed so that we can get a different instance on each point if we change the random seed. Then there's settings to do with the rotation. So we create a vector where we have the rotation variance as the x and the y and the spin variance as the z. Then we multiply those by pi and negative pi. If you didn't know, you can type pi into the value slot of any float value and it will give you the number pi. And then we have the seed input connected again to our seed group input. And to that I just add a random number that I just picked so that it's a different seed than the seed we used over here. I don't know if that really matters if you're calculating a different sort of random, but I did it anyway. So we do essentially the same thing, but for the scale, we're going to subtract our scale variance from the scale to get a minimum value for a random value node, and then the scale goes into the maximum of that. So then our random scale value is going to be from a minimum of the scale value minus the scale value times the amount of scale variance to a maximum of just the scale value. And then we can just pick a random value between 1 and the scale randomness, or the inverse of the scale randomness rather. And then multiply our random uniform scale value times the random scale value per component if you turn the scale randomness up. And then I guess the only other trick here was I have the scale variance max out at 0.99, so it can never be higher than 0.99. And the reason I do that is because if you had the scale variance at 1, when you subtract the scale times 1 from the scale, you'd get 0, which means you could have instances that were literally invisible. So then what we have here is the index, which is which instance we're going to scatter on a point, a random rotation value for how we want to rotate it, and then a random scale value for how big it is. Then depending on what the matched normal value is, we're going to rotate that rotation so that it aligns to the normal vector of the mesh along the z-axis. And we get that normal vector from a switch, which will either be from the normal of the faces that we distributed the points on, or if we're ray casting against a target, it will be from the raycast. And we can decide that based on this Boolean value, which says that if there's more than 0 in the domain size for instances of the raycast target collection. So we have a raycast target, that's a collection. If we count how many instances are in that collection, if it's greater than 0, then we know we have something to raycast against. And so we will use the vector from the hit normal of the raycast as opposed to the vector from the distribute points on faces node. Then that vector is used so that we can align our random rotation that we created for each instance to the normal of the face that that instance is being scattered on. Then that value, along with the index and scale, go into the instance on points node, and we create the instances. I guess we can just look at this while we're here. We also have the input geometry, which in this case is our sort of planes here. If the delete input geometry is checked, then we want to use just the instances that we scattered on the points. If it's false, we want to join the instances with the input geometry and use that instead. And then this is for showing the vertices of the preview mask. If you select that, that overrides everything. Otherwise, it'll show the result. So then, going back to the instance on points node, the one input we didn't look at was the actual points. So let's take a look at how we create those. So the first thing we want to do is see if there's a named attribute with the name of our mask. So that would be if you had a selection on your input geometry, so a vertex group or an attribute created with the geometry nodes or something. And then we're going to use that named attribute as the selection for our distribute points on faces. But there's a catch, because if the attribute doesn't exist, by default it will be false everywhere. So we want to use the attribute if the attribute exists, or if the attribute does not exist, we just want it to be true everywhere. So that optionally allows us to use only a portion of the mesh to scatter points on. Then other than that, it's just these sockets come straight from the distribute points on faces node to our settings so that we control how dense our scatter is, and then if there's a minimum distance that must be kept between the instances. Once we have the points, if there's no raycast target, those points go straight to the instance on points node. If there is an instance in the raycast collection, the same Boolean that we looked at before for the align to the normal setting, then instead of using those points, we're going to use points that are based on the raycast. So let's look at that section. So we have a raycast target come in as a collection, and we want that to be relative to this object. That way we can move the scattering object around, and the raycast target stays in the same place, essentially. We have to realize the instances in that mesh so that we can do a raycast against it. And then we're going to use our mask name again to get a named attribute. We're doing basically the same thing that we did down here. If the attribute does not exist, we're just going to use true everywhere. If the attribute does exist, this not will be false, but we'll have values in the attribute. That is the attribute that we want to sample wherever our raycast hits. And then we want to raycast from the position of our points that we scattered in the negative normal direction of the face that that point was scattered on. So then we can do a raycast and see if we hit anything. If we did not hit anything, or the attribute is less than 0.25. The reason I chose 0.25 is sort of arbitrary. You could make it 0.5. The Boolean is either 0 or 1 because it's converted to a float. And then when you sample from the raycast, it will interpolate, I think, between the vertices of the face that you hit. So 0.25 is a little more generous about including the edges of the selection. If you set it to 1, it would not include anything that was on the border. It would only include what was definitely inside of the selection. So you could play with that, I guess, if you wanted to be very precise about where your selection was. Anyway, if it is not in the selection or the raycast failed to hit anything, we want to delete those points. So we can just do delete geometry on the point, and we're using our points that we distributed on the faces, which is both the origin for the raycast. So this position is referencing the position of these points from the distribute points on faces. And it's also those points that we might want to delete if they're not in the selection or they didn't hit anything. Then we want to set the position of the remaining points so that they are at the position that we hit with the raycast. And we can just use the hit position to do that. And then, like we looked at before, this hit normal value goes to a switch to the align Euler to vector node if we're using the match normal setting. Once we've positioned the remaining points at the hit position of the raycast, that value goes into our switch, which is used when there is a raycast target collection. Otherwise, we use our distributed points on the faces. From there, we're just back to instancing our instances on those points and then outputting the result. The only other thing is here on the, after we realize our raycast target, we can use our selection to make the mesh into points, turn those points into vertices, and then that becomes the preview for the mask if you want to see that. So that is my new scatter node, which replaces the scatter collection and scatter object nodes, which were the old version of this. I think it does everything that those nodes did, plus a bunch of additional things that just makes it more flexible. That node has been added into my geometry node assets, and these are all of the nodes that are in that collection. You can get all of these nodes either on Gumroad or now also on the Blender Market, and if you want to see what all of the nodes are able to do, check out my website. There will be links to all of those in the description. Other than that, that's all I've got for this one. Thanks for watching.